I want to talk about the table in a little bit more detail now. Um, let's say we had an experiment that had 16 rats in it, and rats are subjects and not participants, but go with me on this. That would beg the question of how many degrees of freedom we'd have. And of course, the answer would be, and let me underline this, 15. And let me underline 15. And I know this is slightly crooked, and I'm mortified about that, but I really had trouble with the table. So I've underlined 15 degrees of freedom. And then let's say the next thing that they told us was that we want alpha of O5 two-tailed. Alpha of O5 two-tailed. Okie dokie. So I'll go here and say, okay, alpha in two tails combined, alpha of O5. So it's going to be the fourth one over. I know it's two-tailed, and let me follow over until I get to O5. And then what I'll do is just try to point that. So let me get another color. Will it let me? I think it will, yeah. And I just want to point to it. The critical value then for alpha of O5 two-tailed with 15 degrees of freedom, and again, where did 15 degrees of freedom come from? It came from n equals 16 rats or pigeons or people or what have you. So in that case, there's 2.131, and that'll be plus or minus 2.131. Fair enough. Well, let's say, can I erase? Let's see, I've never done this before. Good job. Let's say I had only 9 participants, and this is people this time. Okay. So how many degrees of freedom would that be? That'd be 8. So let me start here again, and let me go to the red part. That's 8 degrees of freedom. Roger that. So I've got that underlined. And let's say it's alpha of O1 one-tailed. Okay. So I go to one tail, and then I follow it across till I get to O1, and sure enough, it's my old friend. Well, I was going to do an arrow, but I guess it won't let me. Let me just do blue then. It's my old friend 2896. I'm drawing a blue mark toward it. So it was 9 participants, which is 8 degrees of freedom. Alpha of O1 one-tailed. So I go to one tail and I follow it over to O1, 2896. Great. Now I want to take you down. I'll go ahead and erase that to the very bottom there. The use of infinity is figurative. We never use that, but it's meant to demonstrate that if we had an infinitely large sample size, then we would use the z values, as you can see. You'll remember that alpha of O5 two-tailed, here's O5 and two tails, 196. Remember that old friend we had? And remember we had 1.65 because we had to choose between two numbers that were a tie for alpha of O5 for one tail. So again, to demonstrate something, and I really need to draw your attention to this, let me draw this in red again, is down here, and I'm marking red by them, you'll notice that not all the degrees of freedom are listed. So if I had 39 participants, I'd have to go down to 30 degrees of freedom. We do that by convention. If I had 85 participants, we'd go down to 60. We don't round up, we round down. So that's just the way that works. That's a widespread convention. If I had 1,000 participants, I'd use 120 degrees of freedom. But for the first 30 values, they're all listed. No, that's no problem. So I think that'll be interpretable. Another thing I want to draw your attention to is the fact that as your sample size gets lower and lower, and therefore your degrees of freedom get lower and lower, in effect, the researcher is punished. So let's say I only had, 3 subjects in some very unusual experimental design, and I wanted to set alpha of O5 two-tailed. Well, let's first underline that, and here's 3 subjects. Well, how many degrees of freedom is that? 2. And I said, what do we say again? Alpha of O5 two-tailed. Here are 2 tails. I followed over to the right, and look, that's a rather prohibitive value. My gosh, it's 4.303. It's not real inviting. So that suggests that I'm, in a sense, sort of getting penalized, if you will, for having such a low N. I have to do a lot to overcome getting lucky. And this has a way of adjusting for very low degrees of freedom that works against the researcher. But to iterate, let me do just one more. The first thing you need to do is establish your degrees of freedom, which is just n minus 1. So let's say we had 25 participants. Fair enough. So if I've got 25 participants, that's 24 degrees of freedom. Let me underline that in red. And then let's say, okay, it's alpha of O1 two-tailed, alpha of O1 two-tailed. So the first thing I need to do is go to two tails and then just find the alpha. Oh, wow, it's way the heck over here. So it's going to be the far right column. And sure enough, and we'll actually do a problem with that number, it's 2.797. I'd have to overcome two critical values of plus or minus 2.797. So it's not all that involved. It's annoying that you have to find a different value every time depending on your sample size, but it's and to that, for that reason, it's more difficult, you might say, than Z, but it's just an extra step. No biggie. So how do I stop this? I don't know. There goes. And thank you for listening. This is the first time I've ever drawn on something, so I didn't know how to use it.